Hi, today what I want to do is I want to solve problem sheet 8, and the first problem here is to design 3-bit down counters. Down counters are counters that count from count down, right? So a 3-bit down counter will have 8 values, which means 7 to 0 or 0 to 7, and the counter would count from 7, and then it would do 6, 5, 4, 3, 2, 1, 0, right? You want to count that, do this counting, and you want to do this design with T flip-flops to start off with. So what I'm going to do is I'm going to do that on an Excel sheet here. So first of all, let's just write what T flip-flops do. How do T flip-flops function? Now if we say T is the input and Qn, let's say, is the present input, and then we say what is the next input going to be when the clock arrives. So if T is 1, your Qn plus 1 is simply going to be Qn bar, right? So that's the opposite of Qn, and if for our purposes in Excel, I'll just write the bar as a hash here, as a backslash here, okay? And if T is equal to 0, you have the output as Qn itself. Okay, so that's the working of a T flip-flop. Now, using this, let's try to decipher how this counter is going to work. So to do that, what we are going to do is we are first of all, we already said that we need counts from 0 to 7, that's 8 states, so a 3-bit counter, right? So let's write the present inputs. So let's call them Q2, Q1, and Q0. And I'm going to make this font a little bigger so that you're able to see. I should have done that before, but let's do this now. Okay, so that's clear enough, right? Okay, so let's write the combinations for Q2, Q1, and Q0. And of course, the combinations are fairly straightforward. You have 0, 0, 0, you have 0, 0, 1, 0, 1, 0, 0, 1, 1, and then you can write 1, 0, 0. You can actually copy this, isn't it? These four values repeat itself from here, and this is 1, 1, 1. So that's our states. Um, okay. So now, so this is our present state. So in the down counter, once you are at 0, 0, 0, where do you want to go? What's the next state that you want? So let's write the next state as Q2 plus, Q1 plus, and Q0 plus. The plus refers to the next value of the state. So if you are down counting and you are at 0, 0, 0, what's your next state? You want to go to, you're down counting, right? So you want to go to 7. So that's 1, 1, 1. What about if you are at 1, 0, 0, 1? What do you want your next value to be? You want it to be 0, 0, 0, right? 0, 0, 0. If you're at 2, what do you want your next value to be? You want this value to be there, 1. And if you're at 3, you want 2. So basically, you basically want these values to go, right? So, and if you're at 1, 1, 1, you want 1, 1, 0, right? So you're just going one value down, and you can see that this truth table defines that. Okay. So now that we have done that, now we ask the question, okay, so if you want these outputs, what is the T inputs that we need, right? So let me just move this a bit towards here. So these are my, so I can just say these are my present outputs, and I need to increase the font size for this as well, so that, right? And these are my next outputs, And now what I do is I make a new column and I say what are my present inputs to the flip-flops. Now of course the present inputs are to the T flip-flops. So what we have is T2. Oops. So we need to change the font here as well. So you have T2, T1 and T0, right? So what is T2, T1 and T0 going to be? So if you want 1, so your present state is 0 and your next state is 1. So you want the state to change. So if you want the state to change, what should your T value be? It has to be 1, right? Otherwise the change will not happen. So T has to be 1. Similarly for T1, the state has to change from 0 to 1, which means T1 has to be 1 because the state needs to change. From Q0 to Q0 plus as well, there is a change, so the state is 1. Now, for the second, for this row, take a look at this, you have 0, Q2 is 0, and Q2 plus is also 0. So you don't want a change here of the state. So your T2 is going to be 0. Similarly, it's going to be 0 here, and it's going to be 1 here. And so you can kind of fill up all the values that you want. So you can say 0, and here it's again 0, so the state remains the same, so your T is 0. 1, the state is 1 here, and the state is 1, the next state is also 1, so no change, so 0. And then Q0 changes, so you have 1. In the fifth one, Q2 changes, so 1. Q1 changes, 1. And Q0 also changes, right? So all the three values change here. In this value, from 101, we are going to 100. So Q2 doesn't change, Q1 doesn't change, Q0 changes. And then you have 0, 1, 1, and you have 0, 0, 1. Okay, so we have got our present inputs T2, T1 and T0. Okay, so what do we need to do now? Now that we've got our present inputs, so we've got our flip-flops, we have got T2, T1 and T0. So if you want, you can take a look at it this way, isn't it? So if you go to digital circuits, I'm going to just put some T flip-flops here. So here's my T flip-flop. So what we are saying is this is 1, this is 2 and 3. So we have 3 flip-flops, and let's call this, let's just rename these. How do you rename? You just go here, I think. Yeah, okay. So you say U0. Yeah, let's call it U0. Let's call it U1. Okay, the name is already existing, so let's change it to first to U2. U2 1, U1, and then we changed it back to U2. Okay, so those are my 3 T flip-flops. So this is T2, this is T1, and this is T0. And you also have Q2, Q1, and Q0, right? And what you want to do is, using Q0, Q1, and Q2, you want to produce T0, T1, and T2. And you make combinational circuits to do that. Okay? So let's go back to our sheet and try to think about how we're going to do this. So what we want to do is, we want to write T2 as a function of Q0, Q1, and Q2. So how do we do that? So to write a Boolean expression, what we can do is, there are some things that we can easily see, isn't it? So take an example for T0. What is T0 equal to? T0 is simply equal to 1, right? We don't have to do anything. It's just equal to, and 1. And similarly, you can say T1. If you look at T1, what is T1 equal to? You could write k-map and try to resolve t1, but you can just look from observation that t1 is just q0 bar, right? Whenever q0 is 0, t1 is 1. Whenever q0 is 1, this is 0, and so on and so forth. So you can write t1 equal to q0, and we'll just write a backslash for bar. Okay, now let's try to figure out what t2 is. Now t2 is a bit more difficult, isn't it? Because it's not very straightforward as to what is the pattern here, right? So what we can do is we can write a k-map, and let's put q2 q1 on the horizontal axis, and we'll put q0 in the vertical axis, and then let's write the combinations. So we have 0 0, oops, how do we write 0 0? 0 0, nope, I think I'll have to write 0 0 like this, otherwise fairly difficult to write 0 0, it looks like. Okay. Okay, let's write 0 0 0 1 1 1 and 1 0. Those are q2 and q1, right? And on the vertical axis we have just 0 and 1, 0 and 1. So in this case what we can do is we can write what t2 is. T2, just fill these values up, so you get 1 0 0 0, and then you get oh, wait a minute, I'm doing something wrong. So when q2 q1 q0 is 1, it's 1, and then when q2 q1 is 1 0, so 1 0 and 0, there's another 1 here, right? Other than that, all of the values are zeros. So there were only two ones. So one is at 0 0 0, another is at 1 0 0. So 1 0 0 is 1. So you can combine both these, right? You can combine these two values and you can write an expression. So in that, q2 will not appear because q2 takes the value 0 and 1. And what you have is t2 is basically bar of, oops, how do I, q1 bar q0. Let me write a not here as well, so bar, and maybe I'll just put a multiplication sign for and. So it's q1 bar and q0 bar. So that's what t2 is. Okay, so you get t0, t1 and t2, and now you can use these to make a counter, to make the counter. So let's just do that. So let's, t0 is just going to be 1, so t0 is just going to be 1, so I'm just going to put a digital constant, just take a value 1 and attach it there. Okay, what is t1 going to be? T1 is q0 bar, so t1 is q0 bar. Q0 bar is this, so I want to attach this value here to here, right? And then what do we have? T2 is q1 bar and q0 bar. So I need an AND gate. So I got a AND gate from here. Okay, I need to, okay, there you go, that is connected. And then q0 bar, I just get it from here because that was q0 bar, and q1 bar I get it from here. Okay, so that's my counter. And what I can do is I can put a digital clock here, and let's say I change the frequency to 1 hertz so that I can see the changes, because if the values are changing at 1 kilohertz, I won't be able to see it because it will be very, very fast. So I'm going to just put the clock in each of these, And then what I'll do is I'll try to read the voltage from Q0 from each of these values. I need to change the names of these otherwise. So that's going to be 2. No, so that's going to be 2. That's 1. And let's change that to 0. And again, I don't want to name all. Okay, so and then I put a digital uh, pointer here so that I can read the values. So here you go. Okay, and what I can do is I can start the simulation, and if I start it, I think you should be able to. So 0 0 0 1 1 1 1, then 1 1 0 1 0 1 1 0 0 0 1 1 0 1 0 0 0 1 and 0 0 0, and then it should go to 1 1 1 again, and there you go. So that's your down counter, which is working. Okay, now what you can do is you can use the same method to get the counters for J, K and D flip-flops as well, and I won't do it. The solutions are there on the screen, and I think you should be able to take a look. Oh, I should have maximized this a bit so that you can see the simulation. But anyway, what I'll do is I'll put a link to this simulation on the web page so that you can take a look at it if you want to. All right, take care.